Okay, today we are going to take the derivative of sinh x, which is hyperbolic sine x, and it doesn't really have anything to do with sine x. I mean, there's a relationship there, but it's a different set of functions. And what sine hx is, and I'm going to be calling it sinh x because that's a lot easier. What it is e to the x minus e to the negative x over 2. And the reason that we call this sine hx, even though it isn't a sine function per se, is that it has the same relationship to the parabola that the sine functions have to the circle. So where sine functions and cosine, like the trig functions that we know from pre-calculus, parameterize a circle, the hyperbolic trig functions parameterize a parabola. So we're just going to take the derivative of sinh x. And since this is sinh x, we're going to actually take the derivative of this. We could do it using the quotient rule. That's the first option. The first option is the quotient rule. But that's kind of a lot of work when we could just factor out 1/2. Factor out 1/2. So let's do it the second way. So this equals 1/2 times d by dx of e to the x minus e to the negative x over 2. Well, what do we notice? Actually, that's not correct. That is not correct at all because we just got rid of that 2, right? Okay, so this is what we actually have left. Well, now notice that we have a chain rule. We have a chain rule right here. We're going to have a chain rule there. So let's do some side work here. Let's do some side work here for the chain rule. Side work. Okay. The outer function, I'm going to use f and g notation. We have e to the negative x. We're not going to deal with this negative right here. We don't need to. Well, this is actually going to be e to the x composed with negative x, which means if we want to derive this, if we want to take e to the negative x prime, we have to make that e to the negative x, because the derivative of the outer function, e to the x, is just e to the x, multiplied by the derivative of negative x, which is -1, and which ends us up with negative e to the negative x. So that is our derivative of e to the negative x, and we're going to need that in just a moment. We're going to need that. Let me just get this out of the way so we don't get confused. Okay. So now what we're going to, I'm going to go over to the right-hand side, and we're going to just rewrite sinh so we don't get confused. So now what we have is 1/2 of a differentiation of a difference, and we can just take the derivative of each one, right? And subtract the right one, because just like the differentiation of a sum is the sum of its derivatives, the same applies to subtraction. So we're going to have e to the x, because the derivative of e to the x is always e to the x, minus negative e to the negative x. I know that negative doesn't look very good, but visualize it because we have it down here, right? Well, this is going to turn into 1/2 e to the x plus e to the negative x, because these minuses right here, they become a plus. So we're actually going to end up with e to the x plus e to the negative x over 2. Well, that's the derivative of sinh x. What's also interesting, however, and we're going to do this in the next video, is that is cosine hx. This is hyperbolic cosine x.